a supermassive black hole from the dawn of the universe, just 690 million years after the Big Bang, has been discovered by scientists. This is the most distant quasar, a supermassive black hole surrounded by a disk of gas, ever identified, and it will help astronomers to better understand exactly how black holes grew when the universe was first forming. Black holes are a big mystery. They are regions of space where gravity is so strong that nothing, not even light, can escape. Often we think of black holes as forming when a massive star collapses in on itself. However, black holes that formed in the early universe are different. These cannot, in theory, have formed from the collapse of massive stars because the time scales don't match. There would not have been enough time for a star to be born, live and die for it to exist. Keep up with this story and more by subscribing now. An artist's impression of the supermassive black hole. Carnegie Institution for Science. In a study published in Nature, an international team of scientists has now found the most distant, therefore earliest quasar ever discovered. This supermassive black hole, which has a mass 800 million times greater than the Sun, formed when the universe was only 690 million years old. The team found the quasar as part of a project to seek out the most distant supermassive black holes in the universe. Quasars are among the brightest and most distant known celestial objects and are crucial to understanding the early universe, Bram Ben Emmons, from the Max Planck Institute for Astronomy in Germany, said in a statement. Researchers had previously speculated that two exists soon after the Big Bang. Certain conditions must have existed that allowed for the formation of supermassive black holes. About 400,000 years after the initial explosion, the primordial soup of high-energy particles cooled down to become a neutral hydrogen gas. Eventually gravity condensed matter and the first few stars and galaxies were born. Energy released at this time caused the universe to become reionized. The neutral hydrogen became excited and ionized, allowing photons to move through space and allowing the universe to become transparent. The quasar formed when the universe was just 690 million years old. Robin Dienel, courtesy of the Carnegie Institution for Science. After analyzing the quasar, the scientists found a lot of the hydrogen surrounding it is neutral, which suggests that the supermassive black hole formed during the reionization phase after the Big Bang. It was the universe's last major transition and one of the current frontiers of astrophysics. Lead author Eduardo Bernardos, from Carnegie Mellon University, Pennsylvania, said, "Gathering all this mass in fewer than 690 million years is an enormous challenge for theories of supermassive black hole growth. Further observations of the quasar will provide researchers with even more constraints on how black holes in the early universe can form, giving a better insight into what happened just after the Big Bang. Models of evolution will need to be able to explain how it could form the stars needed to produce the observed amounts of dust and heavier chemical elements in such a comparatively short time," Ben Emmons said.